New streetlights will be installed along a section of the highway. The posts for the streetlights will be 7.5 meters tall and made of aluminum. The city can choose to buy the posts shaped like cylinders or the posts shaped like rectangular prisms. The cylindrical posts have a hollow core with aluminum 2.5 centimeters thick and outer diameter of 53.4 centimeters. The rectangular prism posts also have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. The density of aluminum is 2.7 grams per cubic centimeter, and the cost of aluminum is 38 cents per kilogram. If all posts must be the same shape, which post design will cost the town less? How much money will be saved per streetlight post with the less expensive design? Okay, so let's find the volume of both figures first. So let's start with the cylinders. So the cylinders will kind of look like this, with hollow. Let's say this is hollow, and this will have to be 2.5 centimeters because it's 2.5 centimeters thick, and then outer diameter of 53.4 centimeters. So we can just find the volume of the whole cylinder and find the volume of the cylinder inside, and subtract the volume of the cylinder in the inside from the volume of the the volume of the whole cylinder. So we can set up so we can do pi r of the whole cylinder, which is 53.4 divided by 2. That would be 26.7, if I'm not mistaken. Yeah, 26.7. So pi 26.7 squared, pi r squared times the height. We're given that 7.5. Mark this down here for simplicity's sake. 7.5 meters. So it's not centimeters, it's meters. So we have to do 7.5 times 100, because each meter has 100 centimeters. So we multiply this by 7.5 times 100, which is 750. But I'm going to put it here as 7.5 times 100 so that we know like what we're doing. And we have to subtract the volume of the cylinder on the inside. So we can use pi, the radius of the cylinder on the inside. So if the radius of the whole cylinder is 26.7, and we're subtracting 2.5 from that, the radius of the cylinder on the inside will be 24.2, I believe. So 24.2 squared, and with the same height, 7.5 times 100. This is in centimeters. So let me get my calculator. Okay, and let's do this basic arithmetic. So pi times 26.7 squared times 750 minus pi times 24.2 squared times 750 will get you 299,825.7489 cubic centimeters. Okay, so now that we have this value, it says the density of aluminum is 2.7 grams per cubic centimeter. So first we can multiply with the value we just found by 2.7 to find out the amount of grams. And upon entering in the calculator, you get 809,529.52 grams. And it says it's 38 cents per kilogram. So we can divide by 1,000, which will get you 809.52 0.52952. Just shift the decimal place 3 places to the left, and then since it's 38 cents per kilogram, so we can multiply this by 0.38, 0.38, and you get 307, approximately 307.62. So this is the price of the cylinder. Okay, and now we can erase the rest of this first and find out everything else for the prism, rectangular prism. Okay, now for the rectangular prism. I'll do this in blue. Okay, so let's see. The rectangular prism supposed to also have a hollow core. So let's draw a rectangular prism first. It's obviously not drawn to scale. The rectangular prism with height of 7.5 meters. Also has a hollow core. So draw it in another color. Hollow core. Obviously not drawn to scale. Once again, hollow core. So this is 2.5 centimeters. Square base that measures 40 centimeters on each side. 40 centimeters. Okay, that's all we're given. Okay, so same thing here. We just subtract the volume of the rectangular prism on the inside from the volume of the whole rectangular prism. So we can find the length and the width of the square base of the rectangular prism. So what we can do to find out, since there's 2.5 centimeter space here and 2.5 centimeter space here as well, this side is going to be 35. I'm going to use a different color. This side's going to be 35 centimeters, and since it's a square base, all the sides are going to have 35 centimeters. So the area of the rectangular prism on the inside is going to be 35 times, I'm going to use white actually, 35 times 35, which is basically 35 squared times 7.5 times 100, because we're dealing with meters. The 7.5 is meters, actually we find the volume of the whole rectangular prism first. So we can do 40 squared, because 40 times 40 is 40 squared, times 7.5 times 100, because that's in meter. That's converting meters to centimeters, so that we all have a common unit. We have a common unit of centimeters. So that's the volume of the whole rectangular prism, and we can subtract the volume of the smaller rectangular prism, which is 35 squared times 7.5 times 100, and that will get us the actual post itself. So entering this in the calculator, you get 40 squared times 750 minus 35 squared, 35 squared, 35 squared, 35 squared times 750, and you get 281,250 cubic centimeters. And now that you have that, we can find the amount of grams of this sample by multiplying by 2.7, because that's the density of aluminum, and you get 759,375 grams of aluminum. And the cost of aluminum is 38 cents per kilogram, so we can divide by 1,000 to get the kilograms of aluminum. So we just move the decimal place three places right. You get 759.375 kilograms. kilograms of aluminum, and it's 38 cents each, so you can multiply by 0.38. By 0.38. You get $288.5625 dollars. Round it, you get about approximately $288.56. So comparing these two current amounts of money, if all posts must be the same, blah blah, which post and this I call the rectangular prism, I'll call this P. So which post design costs less? The prism will cost less. Prism costs less. How much money will be saved per streetlight post with the less expensive design? Simply do 307.62 minus 288.56, and you'll get your answer, which is 1906.